Jai Hind everyone. This is Akanksha Shukla from Information Technology Department and from Ajay Kumar Garg Engineering College. I am going to discuss one of the topic of the subject data analytics, that is regression model. So basically, what is regression? Regression basically defines the relationship between the dependent variables or independent variables, or in other words we can also say that the relation between the variables where changes in some variables can easily be explained, or what is the reason behind that changes can easily be defined by using the regression models. So with the help of these models we can easily identify the changes or the possible causes of these changes which are occurring between the dependent or independent variables. So explanatory variables basically are termed as the independent variables, and the variables to be explained or to be defined basically are known as dependent variables. Just like the equation is y is equal to bx plus c. So in this equation, what is dependent variable and what is independent variable? So the value of y is dependent upon the value of x. Okay, b and c are the constant values. So the dependent variable or the independent variables, what are the relationship between these two variables, what are the possible causes due to which the changes in the dependent variables can be defined or can be identified, can easily be identified by using the regression model. So regression model basically estimates the nature of the relationship, which I am telling, that between the independent and the independent variables. So regression model basically used to identify or used to estimate the frequency or the nature of the relationship between these two variables. So the change in dependent variables that results from changes in independent variables, just like the size of the relationship, strength of the relationship, what is the statistical significance of the relationship. So these three are some basic parameters which can easily be identified by using the regression model, that what are the changes in the dependent variables to which the independent changes in the dependent variable can be caused from which independent variables, from which value, from which size of the relationship, what is the strength of the relationship between these two variables, and what is the statistical significance between these two variables. So these three parameters can be easily identified by using the regression model. Now here I am going to present some examples which can easily define the relationship between these two variables. So just the first example is telling about the retail price of gasoline in Regina. So dependent variable here, the dependent variable is the retail price of the gasoline in Regina, and the independent variable is the price of the crude oil. So based on the price of crude oil, the price of gasoline in Regina can be changes, or the cause of changes over the dependent variable, that is the retail price of gasoline in Regina, be directly proportional to the price of crude oil, because it is the independent variable. But if this changes, then it will have its direct impact over the dependent variable, which is the retail price of gasoline in Regina. The next one is dependent variable is employment income, and the independent variables might be hours of work, education, occupation, sex, age, region, years of experience, unionization, status, and many more. So these all are the independent variables, but they all have their direct impact over the changes can caused over the dependent variables. So the employment income can be dependent over all these independent variables. Maybe if it is having a larger, or if one is having a higher number of years of experience, then it may be possible that income of that person is more than a less experienced person. So if the female or male, if you are talking about the independent variable, just like sex, so if a gender is male or female, so based on that gender also the employment income can be varied, or we can see easily variations in the employment income directly by having any of these independent variables. Now the last one is price of a product and quantity produced or sold. So quantity sold affected by the price. Just like for example, if the price of any thing is somehow low, so people usually buy that thing people usually used to buy that thing that is having a low price. So quantity, the sold price also, quantity that is sold for that particular part of for that particular thing is basically affected by the price value. Okay, so dependent variable is the quality of the product sold and the independent variable is price. Okay, so here the dependent variable is quantity of product sold and independent variable is price. Means based on price, based on the price, the quantity of the product is going to be sold. And now the price affected by quantity offered for sale. Here the dependent variable is price and the independent variable is quantity of sold. So here these two parameters are given, and based on these two parameters there are two circumstances in which the one circumstance is that dependent variable is quantity of product sold and independent variable is price, and the next one is price affected by quantity offered for sale. So here the dependent variable is price and the independent variable is quantity sold. So these two circumstances can be accomplished based on the particular condition or situation. This is the graph which is showing the first example, that in which the dependent variable is retail price of gasoline Regina and the independent variable is the price of crude oil. Okay, so this is simply the graph which is showing the relationship between these two variables, dependent and independent variables. So we can easily see that this pink line is crude oil price index in 1997, which is equal to 100, and this blue line is regular gasoline prices in Regina. So these two graphs is showing the relationship between the dependent variable and independent variable. Now the next one is what is bivariate and multivariate models inside the regression models. So the bivariate can also be known as or can also be termed as simple regression model. So in which what is the scenario, that only there is one dependent variable and one independent variable. Okay, so there is only a linear or simple kind of relationship between dependent or independent variable. Okay, just like the education or income. Okay, so income is dependent variable and education is independent variable. Okay, based on education the income can be changes. Okay, if you are highly qualified then your income can be more, and if you are less qualified then your income can be low. So here income is a dependent variable and education is a independent variable. Okay, now the next one is multivariate and multi-regression model. Here what happens, the dependent variable is common, that is income. Okay, so the dependent variable is common, that is income, but there are more than one independent variables which are education, sex, experience, age. So based on these variables can also have direct impact over the income, that is direct variable. Just I had shown or I had defined in the previous examples, just like here only, that dependent variable is employment income and independent variables might be work, education, occupation. Okay, so that is similar here. Okay, so in bivariate or simple regression model we have only one, we are always going to have only one dependent variable, but there can be cases in which we have only one independent variable. So if we are having only one independent variable, then that is known as bivariate or simple or linear regression model. And if we are having more than one independent variable, just like in this given example, then we are having a multivariate or multiple regression model. So here we can easily see that this model is having the simultaneous relationship. Okay, oh sorry, in the third example, this is the first one, this is the second one, and this is the third one. In this, the model is having the simultaneous relationship, means price of wheat is also having impact over the quantity of wheat produced, and in the reverse order, quantity of wheat produced is also having its effect over the price of wheat. So here the simultaneous relationship model we can easily identify, or we can easily see in this example. Now, what is bivariate or simple regression model? Here what happens, the regression model equation is y is equal to b naught plus beta 1 x plus epsilon, and x is the independent variable, this x is the independent variable, and this y is the dependent variables. Okay. The model has, this simple regression model has two variables. First one is independent variable, which is also known as, don't be confused with these two words because these two terms are similar, the independent or explanatory variable, both are similar terms, and the dependent variable y, the variable whose variation is to be explained. The dependent variable y is the one, or we can say is that variable whose variation is to be explained with the help of the independent variable, which is known as explanatory variable. So, if we are having the relationship between these two variables x and y in terms of a linear or a straight line, then this kind of relationship we can simply say that simple linear regression model or simple linear regression relationship is existing between these two variables, that is dependent or independent variables. Now, the two parameters here we have to estimate. So, the two parameters which we have to estimate is the slope of the line beta 1. In mathematics, we are already familiar with this equation, y is equal to mx plus c. So, here x and y, these are the x's, and m is the slope of the line. Okay. So, similarly, the slope of the line beta 1, which is written with x, so that is the slope of the line, and y intercept. The intercept of y is known as the b naught, where the line crosses the vertical axis. So, these two parameters we have to estimate. The two parameters which we are going to estimate are beta naught or beta 1. One is slope and the second one is y intercept. The epsilon is the unexplained random or error component. Okay, this is nothing. This is the, we can say that constant or constant value, which is known as the error component, or it is any unexplained or random variable which cannot be predefined earlier. Okay, so this value can be explained or can be defined later on. So, this is simply the regression, simple linear regression equation, and just like in this given equation, y is the dependent variable, x is the independent variable, beta naught is the y intercept, and beta 1 is the slope of the line, and epsilon is the random or error component which is not explained earlier. Now, the regression model is, I had already explained, and data for x or y can be easily obtained from a sample which is initially given. For any data analysis, you are initially given a certain set of data, certain kind of input data. So, data about x and y are obtained from a data sample only. From that sample of values of x and y, we have to estimate the b naught, b0 of beta naught, and b1 of beta 1. Okay, using the least square, or we can also have any other method for these estimation. Okay. So, the resulting estimate of the model which we get is known as y cap is equal to b naught plus b1 x. Here the symbol y cap is termed as y hat. Okay, and it is going to be referred as the predicted values of the dependent variable of that y. So, now y cap is known as the predicted values of the dependent variable y, which is the regression model equation, okay, that are associated with the values of x given in the linear regression model. So, what we have to find out from that particular regression model equation, we have to estimate the b0 of beta naught and b1 of beta 1 from that x or y values of the data sample using the least square method, or you can also use any other mathematical equations or any other mathematical methods for that particular estimations, for obtaining that particular estimation b0 and b1. After estimating these two values, the resulting equation will be now termed as in this way. So, that particular y cap is known as the predicted values of that particular dependent variable y. Now, the relationships The economic theory specifies that the type and structure of the relationships are to be expected, just like historical studies which are conducted by the other researchers in different areas, in different fields, having different issues, having different uh, samples, having different data samples, and that data samples also have their related issues. For example, if we are taking a data sample from just like from one college, and the second data sample we are going to take from another college, then in these two data sets there are some parameters which are related to one another. So these kind of issues, related issues, studies by the other researchers, or different samples which are going to take. So these things basically used to define the relationship between the variables. Speculation about the possible relationships, what can be the outcomes, what can be the predictions for the possible relationships, what are the correlation between the relationship, what are the causes between these two, between the relationship between dependent or independent variables, what are the many theoretical reasons for the estimation of regression relationships, empirical relationships. These all things need to have a theoretical explanation, need to be explained. Now come to the another point, that what are the uses of regression. So the amount of change in the dependent variable which is going to be resultant from the changes in the independent variable only need to be estimated first of all. And just like it is having its various uses in, just like return on investment in human capital, just like in predictions, somewhere we are going to predict the dependent variable values, just like if what are the what is the ratio of the crop to be yield. It is the dependent variable, the crop to be yield, but that dependent variable will have its direct impact from different independent variables, just like weather, the temperature, the rainfall of that particular year. So these are the independent variables which have its direct impact over the dependent variable, that is the yield of a crop in that particular year. So in this kind of usage, we are going to use the regression models. Now the attempt to determine the causes of the phenomena. If there is having a certain phenomena, then what are the causes of that phenomena can be easily identified by using the regression model. And basically regression model we are going to use in the prediction purpose. So prediction and forecasting of the sales, economic growth, just like we are going to predict the rainfall, we are going to predict the weather forecasting, we are going to predict the if we are going to predict the result of next year. So based on historical studies, we are going to based on last year studies, we are going to predict these kind of things. So basically the regression model is used to predict the certain things, support or negate the theoretical models, and it can also be used in modifying and improving the theoretical models and the explanation of that particular theoretical phenomena. Here the some data is given, just like here this is income given, and this is the work per hour, weeks per hour, how much the person is working per hour. Okay, and based on that particular independent variable, how much its income, that is dependent variable, is going to be influenced. This is also the same, but here what we can see, that in this particular data, the hour per week is same, but the income is going to be fluctuated or going to be varied. Okay, so these kind of causes or these kind of regions can easily be identified with the help of regression model. That why, if the hours per week is same, the value of hours per week is same, then why the income is going to be varied in this case. So these kind of things can be easily identified, can easily analyzed in the regression with the use of regression model. Now the income as a function of hours work loaded, it is represented in the form of graph. It is a graphical visualization or graphical representation of that particular data set which is given here. After that, we had find out the value of, we had find out the equation y cap is equal to b naught plus b1 x, and Based on that equation, we are going to draw a straight line. So here in this particular equation, we have what we are going to find out, that there is a straight line which is going between these two dependent or independent variables. It means this is a simple linear regression model. Again, the example is given, okay, and that graph is going to be present here. Now, the next term is outliers. What are the outliers here? So, the extreme values, the real values, which are having no relationship between any data set, or inside the data sample, the data point which is having not a which is having not a any common relationship with other data points are generally termed as an outlier. So, we can also say that the extreme values which are going to distort or which are going to demolish the outcomes can termed as a outlier. It may be an error only, or it may be a very important observation also. So, more than 3 standard deviations from the mean can be termed as the outlier. So, in this given graph, which is the GPA versus time online, where the data set of this graph is already shown by me in the previous slides. In this example, we can see that these two data points can be termed as an outlier because they are far apart from the other data points which are going to be settled or which are going to be plotted in this particular graph. So, that kind of data points which are going to distort the outcome is termed as the outliers only. This is the U-shaped. At some times when we are going to plot the data points over the graph over the XY axis, then we can have a U-shaped graph, U-shaped relationship. Okay, so this graph is showing the U-shaped relationship between the dependent or independent variables. Here the correlation coefficient value is 0.12. Now, the terminologies which are related to the regression analysis are, first one is dependent variable, which is already told by me. So, the main factor in regression analysis which we are going to predict or which we are going to be explained further is called the dependent variables. Also, it is called as target variable. And the independent variable is the factors which are going to affect the dependent variables or which are used to predict the values of the dependent variables. Means independent variables are used to predict the values of the dependent variables. So, that's why it is also known as the predictor. Independent variables are also known as the predictor because based on that values we are going to predict the values of the dependent variable, which is known as the target variable. What are the outliers? It is just like an observation which contains either very low value or very high value in comparison to the other observed values or other observed results in our data samples. So, an outlier may hamper the results, or it should be avoided or should be ignored or nullified. Okay, the next one is multicollinearity. If the independent variables are highly correlated with each other, if you are having more than one independent variable and that independent variables are highly correlated with each other, then that condition is termed as the multicollinearity. So, for a particular data set, we are going to avoid that kind of situation. That particular property, multicollinearity, should not be present in the data set because it creates the problems while we are ranking the most affecting variables. So, that's the main issue, that we are going to avoid that particular condition in our data set. Now, what is the underfitting and overfitting? If your algorithm works well with the training data set but not well with the testing data set, then such problem is known as overfitting. Means if your algorithm is giving the 100% result over the training data set or 100% accuracy over the training data set, but when that particular algorithm is going to be tested with the testing data set, then that particular algorithm is going to give the accuracy of only 50%. Then that condition is known as the overfitting problem. Okay, and if our algorithm does not perfectly work with the training data set and while we are testing with the test data set, that particular algorithm is giving 90% accuracy, then that problem is known as the underfitting problem. Now, I am going to discuss some types of regression. So, there are various types of regressions which we are going to use in our machine learning, in our data analysis, in our data science. So, each regression type is having its own importance in different conditions and different perspective scenarios. Okay, so based on that circumstances, based on that scenarios, we are having to select which kind of regression we are going to use in our particular data set. So these are some different kinds of regression. The first one is linear regression, the second one is logistic, the polynomial, support vector, decision tree, random forest, and ridge regression. Now, what is the linear regression? Basically, it is a statistical regression model which is used only for predictive analysis. So, it is one of the simple and easy algorithm which is going to work on the regression, and basically shows the relationship between the continuous variables. It solves the regression problem in the machine learning. It shows the linear relationship between the dependent and independent variable, just like y is equal to b naught plus b1 x plus c. So, this is a simple linear regression equation. That's why it is called as linear regression. If there is only one input variable x, then such linear regression is called simple linear regression. And if there is more than one input variable, then such linear regression is called multiple linear regression. Okay, that is the difference. That is the only difference between simple linear and multiple linear. Both are linear regression, but in simple linear regression, we are having only one independent variable, and if we are having more than one input or independent variable, then that is known as multiple linear regression. So, the relationship between the variables in the linear regression model can be explained below using the below image. Here we are going to predict the salary of an employee based on the year of experiences. So, just like in the given example or in the given diagram, we are having the income of the particular person based on the experiences of the person. Okay, means here we are having a multiple input variables, just like education, sex, and experience or age. So, based on these multiple variables, we are going to predict the target variable, that is income variable. So, that's why I had not repeated that given same example over here. So, that's the example which is. Now, the next one is logistic regression. It is another supervised learning algorithm. Basically, logistic regression is used for solving the classification problems. What happens in classification problems? We are having a dependent variables in a binary or discrete format, just like such as 0 or 1. So, logistic regression algorithm works with the categorical variables, just like 0, 1, yes, no, true, false, spam, not spam. So, in these kind of problems, just these kind of problem is known as the classification problems. So, logistic regression is basically confined towards the classification problems only. So, it is a predictive analysis algorithm which works on the concept of probability only. So, it is a type of regression, but it is different from the linear regression algorithm, in which in the term in which it is used. And logistic regression uses the sigmoidal activation function, or we can say logistic function, which is a complex cost function. Okay, there are so many activation functions, ReLU, sigmoidal activation function. So, basically the logistic regression uses the sigmoidal function or logistic function. The sigmoidal function is used to model the data in the logistic regression, and the function can be represented as this. Fx is equal to output between the 0 and 1 value. The output between 0 and 1 value can be termed as the Fx. The x is the input to the function, with the input which we are going to give to the function, that is termed as x, and e is the base of the natural logarithm. So, three types of logistic regression. There are three types of logistic regression. First one is binary, which is 0, 1, pass, fail. Then multi, cat, dog, lion, and then ordinal, in which we are going to classify the data set in three values: low, medium, and high. The next one is polynomial regression. It is also a kind of regression model which is used to model the non-linear data set using the linear model. This is the main characteristics of polynomial regression. It is very similar to multiple linear regression, but it fits a non-linear curve between the values of x and corresponding conditional values of y. So, suppose there is a data set which consists of the data points which are present in a non-linear data space or in a non-linear fashion. So, if for that particular kind of cases, the linear regression which will not best fitted to these data points, we are going to use the polynomial regression to cover such kind of data points only. So in the polynomial regression, the original features are transformed into the polynomial features of given degree and then modeled using a linear model. That's why it is, the definition of polynomial regression is that it models the non-linear data set using a linear model only. So it maps the data points which are best fitted using a polynomial line only. Then the next one is ridge regression. It is also the most robust version of the linear regression, in which only a small amount of bias is introduced so that we can get the better long-term predictions. For betterment of the predicted values of the target variable, we are going to have some amount of bias which is introduced in the normal linear regression. So the amount of bias which we are going to add to the model is known as the ridge regression penalty. Okay, now we compute this penalty term by multiplying with the lambda to the square weight of the individual features, and the general linear or polynomial regression will fail if there is high collinearity between the independent variables. To solve these kind of problems, we are generally using the ridge regression, and it is also known as the regularization technique because it regularizes the predictions or long-term predictions. So that's why it is known as the regularization technique, because it reduces the complexity of the model. So it is also called as L2 regularization. It helps or it uses to solve the problems if we are having the more parameters than the sample. Means we are having the we are having less data samples, but the parameters are high or more. Then for such kind of cases, we are going to have a ridge regression. Then the next one is lasso regression. It is also another regularization technique which is used to reduce the complexity of the model, similar to the ridge regression, but except the penalty term contains only the absolute weights instead of the square of weights. Means in this, just like in ridge regression, we are having the square weight of each individual features, but in this lasso regression, we are only having the absolute weights. Okay, so since it is taking only the absolute values, so it can shrink the slope to 0 also, whereas ridge regression can only shrink the slope to near to 0, not to exact 0. So it is known as L1 regularization technique. That's all. Thank you.